Welcome back. We're back into ArcGIS Pro. Going to make some cool stuff today. We're going to work with what is Lab 4? Lab 4, we're working with classifying features by standard methods. Okay, that makes a lot of sense, right? Okay, so we're going to work on Lab 4 today. We're going to create different thematic maps for a crime mapping project by applying different classification methods and different numbers of classes. This stuff gets easier to understand. So anyway, we're going to go ahead and start ArcGIS Pro. We've got it signed in. We're going to go ahead and create a new blank map. We're going to call this Lab 4. And for this, I'm going to call it Lab 4-1 because this is going to be in separate sections. And you're probably going to want to do, well, you are going to make 3 separate maps. Location is going to be, save this in its appropriate folder, labs, okay, but okay again. This stuff is probably still open in your map from the last deal. You can go ahead and close export, and you can close element. Symbology can stay open. I like to have my my 4 standard pane tabs down here, but you can close those as you like. We'll turn off topographic and then we'll get started. Hopefully you've already downloaded and extracted the data for this lab. If you have not, go ahead and do that, then come back. We're going to go ahead and add data from that to our map. So we're going to go to map, add data, navigate to our 4 data, Texas County Crime. Within that, we see that there's a shapefile called texascountycrime.shape. Click that, hit OK, and we'll see that that's added to the map. And so we're going to take a look at the attributes to see what we're working. Yeah, sorry, my son barged in here wanting me to put together his Legos. So here we go. We've got texascountycrime.shape added to the map. We're going to look at the attributes to see what we're looking at here. What kind of data is contained within this. So we'll right click on this and we'll open the attribute table. We'll take a look at the fields. We see that these are counties, right? And it looks like these have crimes for looks like 1994 and then 2002. So there's lots of different attributes in here. And so we're going to use some of these attributes to symbolize and show, things about, to show crime within a county. We're going to use symbology to be able to do that. So let's go ahead and close the attribute table here. We're going to right click here and go to symbology. You don't have to do that every time. If you keep your symbology pane open, you can just select this and go to the symbology pane. And we see that symbology is open for Texas County Crime, right? I'm on number 5 in the instruction. And it's on page 2, and it says under primary symbology, select graduated colors. It's this right here. And this is a different method of symbolizing your layer. And this symbolizes it by quantity. Here we did it by category. We were using unique values. Now we're going to do it by numbers, by quantity. So we're going to click on graduated colors. And we see a bunch of stuff pops up here. This field is asking us by what field do we want to make our colors? I'm trying to read along in the instruction here. It says when symbolizing layers by quantity, field drop-down box will display only numeric fields. And if you remember back in the attribute table, you had your crimes, and then it had the number of those crimes for within each county. Those are numeric fields. Um, if it's a text value, it will not be listed within these fields. So this only shows fields with numbers in, right? Number 6 says choose Berg 02. So burglary 2002. So that's this one here. We'll select that. And our symbology changed some in here to reflect to reflect that it's updated. It updated the symbology. And so in the instruction it says the Berg 02 field represents burglaries recorded in each county of 2002. By default, the values in the field are grouped into five classes, using the natural breaks jinx classification method. And we'll talk more about this, as this goes along. But we say that there's 5 classes, and we can see these 5 different classes here. 0 burglaries through 700 or 676 will fall into this class. 677 to 2,522 will fall into this class, and so on. The color ramp is automatically assigned by ArcGIS Pro. You can change it however you want to change it within here. In the previous instruction, I remember I said I will use color scheme and color ramp interchangeably. That's it's called a color ramp. So anyway, so we'll go on to what is this, page 3, number 7. At the top of the page it says next we'll change the color ramp. Hey, we'll change the color ramp. I'm going to change the color ramp to, I'm going to show names and show all, and I'm going to select blue 5 classes. So we're going to scroll down quite a bit here until we'll find blue 5 classes. Here we go. Remember, we said we're going to choose blue 5 classes because we said we had 5 classes here. It's unnecessary. I mean, you don't want to add, blue 4 classes or blue, 8 classes, 5 classes. So we're going to select that one. Our symbology updates. I'm reading the instruction here. It says the graduated symbology is applied to the map, and the table of contents is updated to show the values represented by each color. Let's look at our table of contents. Hey, we see those colors, listed right here, and here's our 5 classes. This may be useful to crime analysts who want to quickly see where the most burglaries are occurring. It doesn't account, however, for how many people live in a county or the square mileage of a county. You'll explore these next. For now, you will see how the other classification methods affect the map. You've got your first quiz question here on page 4. It asks, the number of counties in each class is different. That should be pretty obvious. I mean, we've got our dark blue here, on down like that. So you can see how many counties fall into each class just by their color. Based on the map visualization, which 2 counties have the highest values? These are the highest values. So what you want to do is look for counties that are represented by this color here. It says, please write down your answers. You will submit your answer to the quiz on the next page. If you need to figure out which counties these are, you can use the Explorer tool. Remember, we can click on a county and see its information. We see that I just clicked on Hudspeth County, right? So if you need to know what counties' names they are, hit the Explorer tool to identify those. Okay, so we're going to go back in the table of contents. We'll go down to symbology. And now we're going to change the number of classes. Okay, so we're going to change this to 3. Class dropdown. And that changes the symbology in our map right here, right? Number of classes will change. and the value ranges will adjust. So now we have different classes here. Um, if you can see now our dark blue, the highest value changed, and now we have more counties included in that dark blue. The instruction says the map reflects the new classification. The highest burglaries class now contains 4 counties. Many counties that previously belonged to separate classes are now grouped together. So on number 9 on page 5, it says open the attribute table for Texas County Crime. Attribute table. Right-click the Berg 02 field. As soon as we find it, we'll do that. Here it is. It says click sort ascending. Right-click on the Berg 02 field again and click statistics. And so a chart will appear over here, and we see our statistics here. We see the median, the mean, the median, the standard deviation, count, min, max, and sum in this pane over here. Histogram will also show next to the attribute table. What that means is here's the attribute table. It appears next to it here. This is a histogram. On the chart, the x-axis shows the range of values in the Berg 02 field. The y-axis is count of features. Let's go back into the attribute table and its symbology. Look at the upper values or the break values. Symbology. There we go. Okay, so the upper value is your break value. If you see here, the break value is where this when we lump everything into a class, we've lumped 0 through 1564 into one class. Its break value is 1654. You can see that the next one starts at 1655. Its break value is 8186. We can see here that, it starts, the new one starts at 8187. So this is its break value right here. Okay, let's look back at our instruction here. Note the upper values are break values: 1564, 8186, and 39275. Click the gray box next to the first row, and then scroll down until you reach the row that shows your first break value of 1564. So that's for this burglary 02 right here. So we're going to scroll down quite a bit. Keep going. There we go. Okay, so we're looking for 13, or we said 1564. This one right here, right? So we're going to go across. We're going to shift, press and hold shift, and then click this gray box here. Now we'll select everything that's within this class. So the instruction says press and hold shift, click, 233 in total. That shows right here 233 in total. There's 254 counties in Texas. 233 of them have been selected. 233 of them are included in this first class. Reading the instruction. Quiz question 2 asks, there are 233 features in the first class. How many features are in the other classes? It's pretty easy to figure out. Some very basic math. All you have to do is, I'm not gonna explain how to do that. Just if you have questions about it, get a hold of me, and I will be happy to give you a little guidance here. Okay, so we've got that taken care of. It says click clear in the attribute table to deselect all our features. In the symbology pane, so we'll go back into the symbology pane here, change the method from natural breaks to equal interval. That's right here. We'll see that these numbers changed over here, right? That's because equal interval, using an equal interval method, the class breaks are equally divided, but still in 3 classes. It places breaks so that each class is the same range of values. Almost all of the values fall into the first class, and we can see that by pulling this down and then looking at this color right here. And this is for just about every county in Texas except, these 4. Yeah, it says almost all of the values fall into the first class. And we can see this by looking at the break value for the first class and locating it in the attribute table. You could do that just as we did it for this last one. You could go in here, select this, scroll all the way down until you see 13092. The burglary here. 13092. I'm looking for it. Am I the right one? There we go. Yeah, it should be this one here. And we can just kind of tell because this number here would fall into this classification here. So we'll just click on that right there. We'll go all the way across, back across, shift, click, 34. Well, I don't know why that says 34. Oh, yeah, I do, because I didn't select those up there. Here we go. We'll click that, scroll all the way down. It should be this one here. Should be 250, I believe. Yep, 250. Almost all of the counties fall into this first class here. So let's go back to the instruction. It says almost all the values. We can see this by looking at the break value in the first class and locating it in the attribute table under the BERG02 field. Unlike the natural breaks method, it is possible to have a class with no values in an equal interval classification. Quiz question 3 asks you, choose equal interval as the classification method and set the number of classes to 4. It's already on equal interval. You just set this class to 4. What is the first break value? First break value is going to be this first thing that pops up right here. I'm not going to tell you that answer. I think you should be able to do this on your own. It's pretty easy to follow. So we'll just move on to the next one on page 6. And this is the last section of this lab. It says in the symbology pane, change the method to quantiles. It says quantiles right here. We'll click that. The quantile method, I'm going to go ahead and clear this. Since that selection no longer applied, the quantile creates classes that have an equal number of features. So you're going to have an equal number of features within each quantile. This one contains 54. This one contains, or actually this is 0 to 54. This is, well, you can do the math. There's going to be an equal amount of counties that fall within these. And you can see, updated, you can see that the, symbology is much different. And it even says in the instruction, it says this map looks much different than the previous classification method. Many more counties now fall within the hottest burglaries class. As this example shows, the way you choose to depict data can provide different impressions, some of which may be misleading. You will have to adjust the classification method again to use natural breaks. What they mean by that, remember when we had really high burglaries in like two counties, two or three counties. I believe it's Harris and maybe Dallas or something like that. And they were colored in that dark blue. But now all of these are dark blue. And what the map kind of says is that even though, this is Tom Green County right here. So what they're saying is Tom Green County is classified in this dark blue. And it is classified the same as Harris County here. We can look to see how many burglaries occurred in Tom Green County. Don't ask me how I know that's Tom Green County. I know the Texas counties. Okay, so there were 1,158 burglaries in Tom Green County. In Harris County, there were 39,275. Far more burglaries in Harris County than in Tom Green County. But they're classified the same color. So this is misleading. So choosing the appropriate classification method is what's going to make your maps represent something something that it is not misleading. So number 13 says, in the symbology pane, change the method to natural breaks and change the number of classes to 7. 7 classes. It actually updated our, this was at 5 classes, it actually updated it to 7. So I'm going to go ahead and close all this down here. I don't need this anymore, I don't think. So the quiz question 4 asks, choose natural breaks as the classification method for the field larceny 1994. So you're going to change this to larceny 1994 and set the number of classes to 4. What is the first break value? And that's it. That's it. That's this part of the lab. We still have 2 more sections to go through. So I'm going to go ahead and click save on this. And I'm going to create a new map. I'm just going to close down ArcMap altogether. Clear out my stuff there. We'll start a new map. Wait for this to start up. And I need to open the instruction for this. We'll go ahead and open a new blank map. We'll call this lab 4-2. We will change this to its right project. Should be here. Yeah, labs. Hit OK. Hit OK. And we're ready to go. This is lab. Second part of this lab. Second part of lab 4. We're going to go into our table of contents. Get there. There we go. Turn off topographic map. We've done everything that we need to do to start. So we know that we have our lab data downloaded. We're going to add 2 identical county crime layers this time. And here's how we're going to do this. We're going to go to map, add data. We're going to find that. There it is. Just add it here. We're going to hit copy. There, paste on map, right click, paste. Now we've got 2 layers for Texas County crime. We're going to change some of the properties of this before we get started. The instruction says we're going to make a population density map overlaid by a dot density map of motor vehicle thefts. So we're going to rename the data frame. It's this from map, and we're going to you can slow click on this, or you can right click on it and go to properties. We'll change this to read motor theft per capita. Right, okay, and then we're going to change the name of this. You can double click it. We'll call this Texas County Crime 1. Hit OK. Double click this and call this Texas County Crime 2. Hit OK. And now I think we're set up correctly. We'll go ahead and move along. We're going to open the Texas County Crime 2 layers attribute table. So that's this one here. Right click attribute table. Pull this up a little bit. See what we're looking at here. Says the population attribute contains the population count for each county. The area underscore square SQ, area square mile. This attribute contains the size of each county in square miles. We're going to divide the population attribute by the square mile attribute to create a ratio of population density for each county. And in instruction, I'm moving on to page 2. It says close the attribute table. Just as long as you know what population, area, square mileage is. So we'll close that and we'll go into the symbology. We're going to change the primary symbology from single symbol to graduated colors. This one right here. We're going to change this field here. We're going to, remember, we're dividing one by the other. We're dividing population and the square mileage. We're going to choose population for this first one. Normalization is another way of saying divided by or to create a ratio of. I'm not sure if they went into this in you guys' statistics classes, but that's what it means. So we're going to drop this down. We're going to drop this to area square mile. And so that's going to divide this by this. And so we're creating a ratio. We're going to set our color scheme to reds, 5 classes. If I can get it to show up. Reds, 5 classes. This is probably going to take a little bit. There's reds. Reds, 5 classes. Hey, it's raining outside. Reds, 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 reds. Come on. There we go. Reds, 5 classes. And so that applied, to our symbology here, our classes. The instruction says, the natural breaks classification method, 5 classes are applied by default. Values in the label column are rounded, but the decimal places are not consistent. And that's true. I mean, we've got no decimal here, so on and so forth. At the top of the symbology pane, we're going to do some advanced symbology. So we're going to click the advanced symbology options here. We're going to expand format labels. In the rounding category here, we're going to round it to 2 decimals. Then we're going to go back to the primary symbology here. And we'll see that this is now standardized. We now have 2 decimals at the end of all of our labels. Yeah, that's about it. In the table of contents, click the checkbox and Texas County Crime 1 to hide the layer. Now we can see the work that we've been doing. Hey, there's all the work that we've been doing. And so quiz question 1 is going to ask you, what are the 3 counties with the greatest population density? Pretty easy to figure out. There's the greatest density. Just find the counties that correspond with that. Okay, so the instruction says graduated colors are one way to represent density. Another way is to use a dot density method. All right, so what we're going to do is we're going to click the checkbox to turn this back on. We're going to create a dot density map that lays on top of our underline. So we're going to go into symbology So we'll right click, symbology, and we're going to change the primary symbology to dot density, all the way close to the bottom. We'll change this field. This first field here is going to be motor vehicle theft, 02. That's this one here. You could put more in, you could put additional fields in there if you wanted to. We don't need to do that. And we see that a bunch of weirdish blue dots appeared on my screen. We'll change the color of the dot so that it has better contrast and stands out from the population density graduated color. We're going to click the symbol next to this here. It's really small, so you might miss it. We're going to click that, and we're going to change that its property. So we're going to change that from that weird purplish blue thing to black. And I'm trying to read what the instruction has here for you. We're going to click black. You know what? Let me step back for a second. I'll go ahead and go with the instruction instead. It says click the symbol next to this and click properties at the top of the pane. Right, we're in properties here. Okay, that's where I was getting confused. Click the color chip. That's this. Click black. That's this. I'm going to go ahead and change the outline color to no color. It doesn't say that in your instruction, and it really doesn't matter that much. But I think it'll look better that way. So we're going to hit apply. Yeah. Otherwise, you'd have a weird blue outline around all your dots here. So yeah, we've changed the color to black for all of these. We're going to go back. Next to the background option, it says click the square. That's this right here. We're going to ensure that the color is set to no color. That's correct. The outline color needs to be no color, so that's going to be this. And we'll hit apply. That changes some the change looks very slight on your computer here, but it basically goes along with, it created some polygons that can interfere with your coloring process. So anyway, we'll click the back button here. So in the dot value field, we're going to enter 100. Right now, the dot value, it's got a dot value of 10. It represents 10 motor vehicle thefts. We're going to change this to 100. And if you click off of it, it'll update. Now it's much different. Now it's much less congested. Each dot represents 100 motor vehicle thefts. These dots don't show where the thefts occurred, right? This theft did, these 100 thefts did not appear in, in this area here for Tom Green County. They just showed the density for the county. Let me see. Let me go back to the instruction here. Dots are also randomly placed within features, so the map you created will likely not have dots in the same place as another. So your dots are going to be different every time. What I create is going to be, what's on my map is going to be different than what you create on your map because it's placed random. And so question 2 asks, you have created a map showing population density that is overlaid by a dot density map of motor vehicle thefts. Which of the following figures shows the correct map for lab 4-2, mapping density? Polygon and dot placement may differ, and it does. Just choose the map that looks closest to what you've created. Not much I can advise on this. It's just you count If you see dots in a county and on one map and don't see dots on another county in the other map, it's not the same. So use that as guidance. Quiz question 3 asks, based on your map visualization, do areas with high motor vehicle thefts have high population density? Well, this was our population density map, and this showed high population density. So what you'll want to do is look at the counties with high population density and see if there are more crimes that occur in those counties. It's a yes or no question. So that's it for this lab. That's it for lab 4.2. You can go ahead and close down. We'll go ahead and save this and then we'll close it. And then we're going to create another map. I'm going to pull up the instruction. Yeah, this is lab 4-3 is using graduated symbols. Graduated symbols will be an important part of your final project. So make sure you pay attention to this. We're going to create a new blank template map. We're going to call this lab 4-3. Make sure it goes in the right spot. Let me make sure that went in the right spot there. Yeah. Okay. Okay, so it says start ArcGIS Pro, create a new blank map, and create a new project by calling blah, blah, blah. Turn this off. You should be used to this by now. Add Texas County Crime shape to the map. Easy stuff. Okay, it's going to show up here. We're going to rename the map frame. We're going to call this Assault. Okay. Open the attribute table. Scroll to the right to see the aggravated assault column. It's going to be this one here. Took no scrolling. And we're going to click on it and hit sort descending. Just a good idea to see what we're looking at. And so these are the aggravated assaults for each county. Bexar County had this many, Tarrant County had this many, El Paso had this many, and so on. For this, we're going to use a natural breaks classification to symbolize data with 5 classes. Let's go ahead and close this. We're going to close the attribute table. We're going to go into symbology, so right-click symbology. And we're going to change our primary symbology to graduated symbols. It's this right here. This field, we need to tell it, what it wants to base its symbology or its symbols on. So, and we said it was aggravated assault 2002, so that's what we're going to find. That's this one here. We're not making a ratio, so we don't need to normalize. Defaults and natural breaks. And we've got 5 classes. Let's see here in the instruction. It says 5 differently sized symbols are shown representing 5 ranges. That's this here. You'll change the symbol template to something more appropriate. Click the table, or I'm sorry, template button, and then click gallery at the top. It's going to be here. Gallery is selected. In the symbol selector, select circle 1. And we'll click properties. And we're going to change that from a black color to black color. We're going to click the color chip and change it to poinsettia red. And then we'll click apply. That changes to poinsettia red. Look at that. Click the square next to the background go back here. We're going to click this square in the background. We're going to scroll through the options for gallery. Actually, hold on. I'm reading the instruction here. How they want you to do this. Scroll through the options and select yellow pastel. Here it is. No, here it is. Yeah, yellow pastel. So we'll select that as our background. And that didn't change well, it changed the symbology of Texas County crime, but it um, it made it to where you didn't need these unique values to be able to do that. You have this, classification, and then it shows your background as that pastel yellow. It's kind of difficult to explain. But basically, the template is what's like on top of it, and this would be otherwise. This is your single symbol. If we had kept it at single symbol, you would color it in this color, but then you wouldn't have a way to put the dots on top, right? And that's how we do this. Let's see. So we've done that. We're going to change the minimum size in the instruction. What page are we on here? Page 1. Minimum size to 3. Oh, wrong way. There we go. And the maximum size to 20. In the label column, double click 0 through 198 to change its text. So we're going to type less than 199. And that's true because this is less than 198 right here. Less than or equal to. For the remaining labels, we're going to replace the hyphens with a 2. It's just easier to read these things this way. And to do that, you just kind of slow click on it until it turns into something you can edit. Enter, and then we've changed all those. And if we go back into our table of contents, our labels are now changed, right? So that's why we do that. You'll see the updated symbology and label changes reflected there. Great. Moving on to page 2. You have created a map showing assaults in the year 2002. After following the steps in the instruction for this lab, which of the following features shows the correct map? View all 3 figures and choose the best one. Please write down your answers. You will submit your answer into the quiz on the next page. Pretty easy stuff. Not much to really go over there. Just match your map with the examples in the quiz. So pretty easy stuff. Quiz question 2 asks, are a greater number of assault incidents located in counties with the higher population count? You'll have to think back to your previous labs for this stuff, but the answer should be pretty obvious. So write down the answer. It's a yes or no question. So write down your answer and you'll submit that in the quiz. And that about wraps it up for lab 3. How long did this take? Hey, 43 minutes. Not bad. Anyway, if you have any questions, as always, this is not that difficult. You don't have to do a layout for this, this week. Some of you will be glad for this. Yeah, if you guys have any questions about this stuff, get in touch with me or any of the other TAs, and I'm usually available most quickly through GroupMe. So get in touch, and I will explain things as best as possible.